Okay, so last case we did was substrate inhibition, which is when you add too much substrate to your reaction. It ends up you end up getting a less of a product formation rate. How do you avoid substrate inhibition? Well, what if there was a way to mathematically determine the optimal substrate concentration that you should add to your reaction? And the thing is, there is actually an optimal way you can do this. And if you're familiar with, if you're taking a calculus course, whenever you're asked to find an optimum point, you're always taught to set the derivative to 0 and solve for the independent variable. And here you can actually do the same thing. You can actually take the partial derivative of the reaction rate V and derive it partially with respect to S, and then you solve for when that equals to 0, and what you'll get when S is the optimal S value. So I can write that mathematically. So we want partial derivative of the reaction speed over S equals 0, and for that S will be S opt, we'll call that. Okay, so that's what we want to find. What do we do? In this case, it's not so bad. There's actually other kinds of reaction rates where the math gets really messy, but in this case, it's not too bad actually to solve for the optimal substrate concentration that you should be adding. So let me write it on the side, small. So to get this derivative, we need to use the quotient rule. There's different ways you can write it out, but basically take derivative of f multiplied by g minus derivative of g multiplied by f over g squared, where the numerator is f, these are functions, and the denominator is g. Okay, let's find what that is. And then we'll be setting it to 0. So 0 equals g. Whoops, forgot that is squared. F prime. Well, what is the derivative of that? It just ends up being Vm. Minus, see, now it's going to be messy. Because the thing is, whenever I use the quotient rule, you have to take so much space horizontally. We need the derivative of the bottom function. Like, that cancels out, that's 1, and that's 2s. And we multiply it by f. And that's all over g squared. Oh no, that's gonna be messy. Oh shit. What am I getting into? No, it's not too bad, it's just arithmetic. Okay, and we simplify it. You'll actually see something nice. You can immediately multiply by this denominator on both sides. See, that's 0? So you end up getting it really clean. And then you can just move this to the other side. Let's just do that. Okay, so see, sometimes you'll get lucky and you'll find ways to easily clean up the equations. Remember what the goal is. We need to solve, we have to isolate this in terms of S to find the optimal concentration, and you'll see it's actually a function of these other variables. For this, I guess we just redistribute and then we'll factor out S. And you'll see that like terms appear on both sides. See that? Just cancel those out. We can move this to the other side. You see 2 of that and 1 of that. We just move it to the side and subtract. And you see it's actually getting really easy. You can cancel the VMs out. Okay, good. And we take the square root. So S opt is really just the root of this. And we know that these are just going to be positive constants by definition. And we just take the root of that. And you know that when you take the square root, it can be positive or negative, but you'll just take the positive for concentration because this is a practical application. And there you go, you have the optimal amount of substrate that you need to add to your reaction. And by doing this, not only will you prevent substrate inhibition from happening, but you'll even have found the substrate concentration that will max out your product formation rate. Perfect. So this one was very easy to solve. Sometimes what happens with these kinds of problems is if the rate is different, what will happen is you'll not see this one only has s squared, so we can actually just take the root of that. But the problem is that sometimes in these problems you'll have s squared and s somewhere else, and then you'll just have to use the quadratic formula and it becomes a big mess. But in this kind of problem, it's actually very nice and easy to solve. Like, look at that. And then would you have thought that the optimal substrate concentration is just a function of some of the other constants within the chemical reactions, like these reactions taking place? Wow, that's actually really easy. Look at that. And there you have it. Hope you enjoyed the video.